Debug is completed. Click on the switch. Okay. Then you know how to open the console also. Same procedure. How will open the console? Go to command cell console. Command cell console. Then here we'll click on new. What is that like? Light D11 data logger. So home port, that is COM 29. I already verified by going to task manager and I'm checking. See port rate, everything at as default. Then click on to finish. Click on to OK. Then again click on to resume. So here you can see your light sample will be in the format of buffer. So give me some light, values will be changed. That's a thing. Okay? Understood? You're getting some values? If you're getting? Okay, good. So to create a machine learning model, our data set should be splitted and labeled data set. If you are creating customized machine learning model, that time you have to collect the sensor values. Then you have to split it in the Excel. Then only you can able to go and create machine learning model. Now it's perfect to create machine learning model. No need to split and label the data set. Which sensor data is fine for us to create machine learning model. So what I will do, I will just close this one. Here you can see one terminal. Disconnect is there. I will disconnect it. Then I will close this console. Then I will click on this run icon. So everything will be closed. Then we will install Nano Edge Studio. That's the second step I want to create. Second step. Data logger is complete. Where I think we erased. Data logger is done. Then go to the second step. Then what is the second step? Nano Edge AI ML model creation. So you do one thing. Data logger is completed, right? I want to repeat again. It's done. Then we'll go to next step. Nano Edge AI. So I think in your laptop it's not installed. Right? Go to Chrome, type there Nano AI Studio. Come. Go to Chrome, type there Nano Edge AI Studio. Okay, click on enter. Go to first link STMicroelectronics. First link from STMicroelectronics. Then scroll down. Scroll down. So here you can see. Then go to site. I'm going fast. Am I going fast? Go to site. You are all in the same page. Here, fill all the credential. Email ID should be valid. Same thing. Okay. Once it is done, when the credentials are done, just click on to download Technology Studio. It's around 300 MB. It will take around 1 or 2 minutes. Download Nano 8 GI Studio. Nano 8 GI Studio is a free and automated software from ST itself. It will help you to deploy machine learning model into your microcontroller. And it will ask you for license. Once you are downloading Nano 8 GI Studio, it will ask you on license. That license will be there in your mail. Just copy and paste it. For student use, they will give a license valid for 2 weeks. 2 weeks it will get lapsed. Once it is completed, let me know. It's around 350 MB. It will take around 1 or 2 minutes. Hardly. Its downloading is completed. It will ask you for license key. License key will be in your mail. Just copy. Over 2 weeks, you have to migrate all the project. Otherwise, the license will get lost. Nano AI Studio is a free and automated software from STMicroelectronics which helps engineering students to integrate machine learning model into microcontroller. So it is very beginner friendly. Since you guys are from electronics and public background, right? So you don't need pair of coding, programming and all. So it is built for engineering students from electronics stream. You don't require any sort of coding here. You require sensors and that should be in the format of buffer. So that is the one requirement to create machine learning model. Okay, so basically machine learning model means you have mind programming Python programming right? So you can create, you can build your own neural network model, then CNN model, AI model and all. You can build into microcontroller. There is one add-on to. If you are using nano edge, simply you can deploy it into microcontroller. There are some steps, some criteria are there. Okay, it will take some time. Download for Windows, not for Ubuntu. 300, 320 something. Done. Please complete and let me know. I'm waiting for your input. Once it is downloaded, install it. ST is AI suit is there. I will explain that. This one page called as ST8 suit. There are, you can see so many case studies from ST itself. If you are reading on one of the link, you can see there will be so many use cases and we can work on it. There will be case studies, in codes for that, and also everything. Means how to work, means software you should use, all the things are listed here. See, there are so many use cases. You can take one use case and you can put this platform and you can show it to your officer. And you can use your resume, LinkedIn, like that. So many things. If I open one link, yesterday I discussed we can integrate or we can create a model of rock paper scissors. So this is one application. So here we are integrating one time of flight sensor 53 LAT A11 expansion board is there. You can integrate with Arduino also, Nano also, anything you can use. Here what they are doing, they are interfacing what 53LADA type of light sensor to STMicro. So they are training a model to detect gestures like store members, these are all. So that is a log members, these are one application. Simple. And you can use for the people who have speech ability. They will be communicating through gestures. So like that, you can try different gesture and you can deploy it to the microcontroller. So whenever they are showing the gesture, it will be displayed here in the LCD module. Like so many applications. See, read the tutorial, codes, everything is there. Sensor, data, resource, everything is listed there. Then not only that, motor fault detection classification. Same thing, vibration I told yesterday. In industry there will be hundreds of motor. So whenever motor is working perfectly, vibration pattern will be same. Whenever motor is not working perfectly, vibration pattern will be different. Abnormal vibration will happen. So we will collect normal vibration pattern, abnormal vibration pattern also. Then we will create an anomaly detection model. Then we will deploy each and every model. So it is a predictive maintenance. Before priorly we will get the data like whether the model is working or not. So before we will get things in HCI models, deployment is a single standard device. Then like washing machine, handwriting recognition. See, these are the implementation of AI into microcontroller in real time. See, anomaly detection in fan, same thing. People detection and people counting. This is by interfacing camera module to our new board is an S747 Discovery board. It's a higher end. M4 and M7 processor is a dual processor or microcontroller board is there. Using that microcontroller, you can interface camera module also. So that is one advantage in so many use cases. Like there are so many pages, you can just go through it, these kind of things and gesture recognition, so many things. And also, maybe in Hyderabad, I don't know, if you are traveling in Kerala, there is what AI camera. You know, AI camera. Suppose you are not wearing seat belt or if you are going without helmet, soon after you are reaching home, you will get the charge. In my car, I have 1,005 like that. So AI camera is there everywhere. If I am exceeding 80 kilometers per hour, it will automatically give me charge. So it is also HGI application. So you are thinking, if I do this kind of model, there is no practical use. Practical use is there. If submit it to the conference, you can publish a paper, and you can collaborate with other company, and you can create a model. Like that. Stabilizer is there. Stabilizer, you know, stabilizer. For fridge, washing machine, not we are using stabilizer. The stabilizer is a kind of starter. In Viga, comparison for social. He created the stabilizer and he sold it for one company and created a product and he is there everywhere. Now there is no fridge without stabilizer. We are scared. But I'm going to make this one was functioning now. Like that, it's starting doing and you can do the patent. So, kind of like like integrating AI into your microcontroller, into your program. It's basically it's engineering. So you have to think in a product area, how are you going to contribute to my society? So like that you can deploy, you can also do drones, anomalies in drone, if you want to be more towards anomaly. Okay, but then why you are solving it? Okay, is that downloaded Nano GS Studio? I think now it got downloaded. Yes. Yes. Okay, Nano GS Studio. It is asking me to update. License or also you are now. Just wait for some time. Let me update this one. This type of product you can use for your mini project, main project and all. So this is what HCL project. Like that you can do. There is no expense. Like 10 20 rupees one sensor, one microcontroller. You can work with all the peripheral. So practical experience will be more. Theory knowledge also will get. Which version you install? 5.1.1. See, as I discussed, Nanometer Studio, it's a free and automated software where you can able to build your own customized machine learning model just using sensor sample that should be in the format before. To create machine learning model, first we created data logger, right? Data logger code we created. If you don't want to create data logger code, or you are lazy to create, or you want to completely create same faster means, here one option is there called as data logger. If you see the data logger, you just want to select your microcontroller and your sensor. Automatically it's down. You just want to flash that differ. Just simple as that. You have so many codes are there. You can use data logger option. Suppose you calculate some data and you want to trim the data or cut the data, something you want to do, data manipulation. Then I can use data manipulation. Or if you want to find some sampling rate, you can use the option called as sampling finder and feature importance. You can do that. Okay. If you are new towards nano chain or you don't know how to work on nano chain, that time you can use this MOOC option. Course are there. Tutorial links, nano chain tutorial links, and also MOOC for data logging and integration. Everything is there. Then tutorial for class classification. Then so many other things. And also down you can see so many use case also. Arc fault detection. Then how to ensure stability. So many things. What use case you can take and you can work on that. How to detect and classify linear actuators using AI, nano AGI, same use case. See how to detect DC, how to perform low power under injection fan using embedded AI sensors. Like that. Do whatever you want based on your use case. Click on the new project. Click on the new project. So here in Nano Studio, you can able to create four different kinds of machine learning model. The first one, detect anomalies in your signal with on-device learning. Means the same thing which we are going to do, that is anomaly detection. Now, no signal also being detecting. This is not a normal signal and training the model will get to know. Anything happens for normal signal, it will detect as abnormal. Like that. Second one, classify variations of your signal. That is nothing. It's classification. Suppose you want to classify different source signal. If you are a traffic police, you want to classify some students, some like that. So that will be this one. If you want to classify the gestures, what means motions and can use this one. So name qualities you can classify. Different temperatures you can classify like that. If one class will be there, any abnormalities happens to the one class, it will be taken as abnormal. Not once. Extrapolation. This extrapolation, have you heard before? Extrapolation is nothing but future prediction model. Future prediction model. In your phone, you will get a notification, right? It might rain at 3 or at 4. So that is what is future prediction model. You have to make future predicting. Sometimes in 5 years before, they used to tell December 6th, tsunami will come or earthquake will come. So like that, future prediction model. That is what is extrapolation. Here we require large amount of data. Then only you can able to create a machine learning model in extrapolation, like 5,000, 10,000 samples of data is required. So which one we are going to create? The first one. So we're going to create. So it is very simple. To create a machine learning model in Nano Studio, it's very simple. It is like creating an SBI account. If you are creating SBI account in your SBI, you can see this kind of thing. First you fill your things, then your PAN card details, Aadhaar card details like that. So first, project settings. So project settings, click here in the pencil icon. So name your project. What is your project? Light globally detection. So once naming is done, click on to the save icon. Light anomaly detection. See, there are so many customized machine learning model creation also. You can do it Google Colab. If you want to, now you will be thinking only Android should I can integrate machine learning model. It's not like that. You can create your own model using Google Colab, Twitter, or Go. Okay, and then you want to use XCube AI error feature. Light anomaly detection is that a then description. Next time, whenever you are opening this project, let's see what is our aim to detect abnormal light patterns from normal light patterns. So like that, you can give description based on your wish. You can give description. Next time, whenever you are opening, you have to understand. Power supply is not there. You are not feeling hot. You are in like inside oven. Will break now. No. Okay. Needless. Okay. Then memory footprint. No need to change anything. This settings as default itself. Let 32 KB RAM by default it will come. Target selector. What we will do here? Select your microcontroller. So which microcontroller we are using? PL4 PL4 S5I IoT01A. So here you can see where it is. PL4. What is your here? Ultra low power MCU. Then here which sensor we will select? Everything is done. We selected. We named our project. Then we have to select our sensor. Which sensor we will select here? Which sensor? Here, 1, 2, 3, 4, 5, 6 sensors are listed. Which sensor we will select? Which one? Microphone. Who said microphone? Which one will select? See, our sensor is not listed here. So we should go to generic. So click on to generic. Access. What? Then click on to save. That is done. Then go to second regular signal and amplifier signal. Both are there. So do one thing. Here, click on to regular signal. Click on to regular signal. Then which option we will select? If you want to add already customized data set from cable or some other site means then use import signal from file. Now nothing, no signals are there in our file. So we have to use log signal from serial USB. So click on the log signal from serial USB. And this page will get appeared. Here, which one we will use? So my T, no, my ST link is connected to COM29. Yours will be different. So here baud rate, maximum number of line is 200. Maximum number of line make it 200. Maximum number of line make it 200. So for normal, make your phone and normal you give light sample like this. Here you are going to collect signal. Okay. For collecting normal light signal, you just give like this. Turn on your flashlight continuously till 200 number of lights we collected. Next, once it is done, after collecting normal signal, you go to complete the signal. Then go to like on off. Just press on the flashlight and the synthetic current is down now. You just go to the answer. Okay. Just click on to start and turn on your flash. Click on to start. See here. That one. You are doing exactly opposite what I am saying. See, for normal, full time, imagine as a straight line. We are collecting normal light sample. So it will be full time flowing. Full time flowing signal is completed. After time we should try thinking. Okay. You collected out 50 sample. You should collect 200. Then only you can accurate model. Not like 50. It's like you are training your brain. If you have less data, you will complicate. I don't know. If you are studying for one day before exam, it is very difficult to pass. If you are preparing for exams, you have good knowledge, you get good data about and right now. So like that, to train your model perfectly. Example also, when you speak about using sensor, it will not, we cannot get the chance to differentiate each other. We will not like that. So, just explain what dynamic test was. What is dynamic test and what are they? Okay. Okay. What is static test? Okay. No issues. Anyone? What is static and dynamic machine learning model? What? That's Every signal is completed. Click on to normal signal. Same procedure. Select your core port. Max the number of lanes. Make it 200. And make it as pleasing. One. So you can see the variation in data. Should say changing. I collected samples. You should give light sample to sensor, not to microcontroller. Okay. Second, then import same procedure. Now you collect a normal signal, abnormal signal also. And once it is done, see these things, abnormal signal graph, normal signal graph you can use for your record purpose. Then third step. Once it is done, go for third step. So the third step is called as benchmarking step. So benchmark is something called nanowatt cloud server contains 5 millions of ML libraries. Based on your sensor input, it will give you a model. Which model is best suited for your sample sample? It will give you like that. So you have to run your benchmark for 3 to 4 minutes. It will test you maximum number of ML libraries, ML models. Okay? So just click add benchmark and again stop benchmark. So let the benchmark run for 3 to 4 minutes. So you can see here, number of HF libraries be increasing. As I said, there are 5 millions of ML libraries in the cloud. It will test you which model will be good for your sensor sample. Then it will give the best suited ML model in the next validation step. Now you can see P92, it is increasing. In left step is the other requirement is small. So it is increasing. So you can see. See, whenever I tell machine learning integrating into microcontroller, that time one concept will be there in your mind. How I can integrate machine learning model into microcontroller? What about memory size and all? So microcontroller that's right. So here you can see your model consumes only 3.8 KB and 0.6 KB something your flash. Okay, so easily you can able to deploy it, right? So it's very simple. So down you can see transmission matrix source you can see, and if I scroll down, if I scroll down, you can see number of machine learning iteration. Since this is a dynamic model means this your machine learning model continuously will train the data. For the input, it's training again and again. Okay, that's dynamic model. It change the pattern. This is based on learning. So iteration means you have to train your model till 25 number of cycles. Then only you will get proper output. Dynamic means once you have built, some sampling will get the output. So static means like that. Dynamic means it will be keep on changing. Based on the training you are doing, it is changing. So that is the advantage of this advantage model. And it is my pipeline model, how it is to the piece of structure, you know, right? These are the terms in machine learning. So that basically the report, so report, it should not take 100 200 number of items. Okay, it will take longer time to train the model. Next, you have to get E30, 40 like that. Once the running gets for 3 to 4 minutes, you can stop it. Smart for 3 to 4 minutes. Is that done? Everyone? Benchmark you can run for 3 to 4 minutes, then you can stop it. Now I am posting. I'm getting iteration of 24. Then you can go for validation. So benchmark you run. Then in validation you can your Nano Studio shows for ML model for your sensor sample. So here you can see this is the best for ML model. The crowd now you can repeat sir. This is the best suited, most suited ML model for your sensor sample. So you can get the record. This is ICM model. ZSM is also there. MUI is also there. And RAM consume 4.3 KB of RAM. Flash 4.2 KB. Then minimum number of iteration 25 years showing. Okay. Then balance accuracy. Accuracy is nothing for your model accuracy itself. Your model is 85, 89% accurate. That's it. Then before deploying the machine learning model into hardware, you can test in yourself whether the model is working or not. So that step is called a serial emulator. Serial emulator. Here you can click. You go to serial emulator. Serial emulator. Second, okay. Serial emulator means the testing platform where you can able to test whether your model is working or not. So here, select your COM port. So I am selecting COM 29. Create test for data. So my address is 25. I will keep I will 24. I will give 40 number of cycle to train. So just train the model with one example. Now my model is in learning phase. Now my model is learning. It's in learning phase. This is my normal sample I am giving. So once training is done, now go to detection tab will get enabled. So this go to detection it will go. So if I click on to go to detection, it will go to another page. So here not to give maximum number of lines. Here we are just detecting, right? So just select your COM code. It's already selected COM 29. Then I am just click on to start. So here normal light I am giving. 2% similarity. It's reducing. See, my model is not accurate because I collected about 50 number of lines. It's showing disrupt. Yours, test yours, you collect 200 number of lines, right? It's not that accurate. It's going till 80, 80, 85, like that. If I remove, it's showing reduced. It's not showing 100. To be yours more accurate. But I get 200 number of lines, right? So just check whether your model is working or not. 98% it's working. You checked in serial emulator. That's all. Whenever you are going for competitive hackathons, that means you have to train your model with 10,000 number of lines. Very perfect. You are getting my point. I tried only 50 number of data. It will get it will not get the capability to train or get the number of. So it will take some time. Less accuracy I'm getting. Also, not working. Here also it's working. Cancel this page. Then go to deployment. Then here you can see deployment. Deployment also you can see. is get library. Download and save it in your desktop. Okay, you understood the step? Any doubts? Just record whatever we did in Android Studio. It's very simple or difficult. If you know how to write data over code, it's simple. Otherwise, it will be difficult. So second step also completed. Don't worry. Once HCA project is completed, I will leave you. Don't worry. So next step is the deployment. Shall we move? Deployment. So here, see here it's not showing like normal, abnormal again. Normal and normal detected by similarity score. For normal, it is showing 100% similarity score. For abnormal, reduced similarity score. So you can keep a threshold in your deployment code if is less than 90, less than 80, it should show abnormal, my red LED should glow. If it's normal above 90, green LED should glow. Like that you can take it. You can do like that. Based on the similarity score, you will get the output. Okay? Then close Android Studio, close everything, come back Cupid. See, this is the extracted zip folder. The zip folder which I am getting to deployment. One file will get downloaded, right? In deployment stage, one ML model will get downloaded. So if you are opening that zip package, whatever you can do, download from download chain. If you are opening the program, you can see nano HCI.h, metadata libnea.a. So nano HCI.h is an amplifier to use ML libraries from nano.js. So this is an amplifier you have to add. LNA is an encrypted Python model. It's an encrypted way. You can't able to read it. It's a library file. If I'm opening, it will be in an encrypted format. You can't able to read it. So these two files, integration of machine learning into microcontroller means these two files will be adding, not metadata. LAB dot A and nanoHA.h. Okay. As you know, like .h file will be adding inside INC folder. All the .h file we are adding, and .c file src. .a we have to add these two files. Okay, this nanoHA.h we can add in INC folder. But where we will add this .a library file? So that time we have to create one lib folder. Okay, so that's a simple step here. Nano HA.h here lib NEI.h. Simple. Then source we are not we will use different main.c file. Okay, don't get confused. All the library files we are adding in library lib folder. All the hand file we are adding into a lib folder, and source file.c file will be adding in src folder. Okay, see here. If you are opening here, you can see this is a zip file. Zip file. Go back and extract that zip file. Go back and just extract it. Extract all. Click on to enter. Extract it. Here you should see that zip should go. Otherwise, whenever you are copying and pasting, it will not get pasted. It will be like that. many section. Then we do deployment project. Create a new project, then anomaly detection or lightning anomaly detection, and enable the pins like B2C, four pins, then add different height and different also. Same step. Then enable all the pins, add the amplifier. The same step, whatever we are doing from morning, just do the same step. That I am not explaining again. Then it's asking to create a new plugin. Give me error. Okay. Okay. Listen, those who haven't done, I will explain again once more. First, we'll clear all the pages, whatever is open here. See? So, same step I am repeating again and again. Code selector, select your code, PL for S5, I to 0 click on to next, name it as height element mention, click on to finish, click on to yes. Sometime. Here are the pins. Select VB6, print as you start on DX, VB7, start on RX, then VB8, I2C1 SCL, VB9, I2C1 SDA, pins are yellow in color, go to connectivity, make it as fully enabled, then you want one, make it as asynchronous, make all the pins green in color, press Ctrl S, generate your main.c file. Okay, so here inside core folder, inside INC folder, I will add ph1750.x. So it is there in previous folder. I'll just paste it here. Okay. Then listen. I hope everyone completed till this step. Right. Then you are waiting for next step. Here we have to add two files. One nano8ti.h, then labneai.a. Okay. So right click here. Light anomaly detection. Just right click here. Go to new. See what we are going to do. I'll just tell you. We are creating one folder. AEAI folder we will create. Inside we will create two more subfolder, INC and LAB. Why INC and LAB? Because these two we want to add. So inside that we will add dot h lab neai dot a. So these two files we are going to add here by creating folder, subfolder like this. So first, right click on your project, go to new and in the folder. So what name of folder? NEA. NEAI. Click on to finish. So here you can see under driver NEAI folder appeared. Yes or no? NEAI folder appeared. Again, is that okay done? No. Here? No. Where is that? Backside? No. Yes. See, this is important. So that's why I'm asking everyone done, no, no. So click on to Nano HCI, this folder, NEI folder. Nano HCI folder. Click on to this. After creating this folder, you may get this folder NEI. You got or not? Then again, right click there. Go to new. Again, create a folder. Create INC. I should be capital, NC should be small. So inside NEI folder, create this INC folder. Then again, we have to create one more folder inside INC. So again, right click there, go to new folder, LIB. L should be capital, I should be small, B should be small. So here you can see inside INC folder, two subfolder came. You're getting my point? Okay. So inside INC, copy that nano HCI.h. Okay, just a minute. Where it is? Okay. So here, go here, copy it. Nano HCI.h. Copy. Then, since it's a header file, and paste it inside INC folder. Okay, is that done? Then again go back. Copy this labnei.h. Dot a. Again, copy this. Copy it. Then paste it here. LAB folder. Paste it. So you can see the same thing. Whatever I put there, exact things we have written here also. In yours also same, right? If I am closing this expansion, it should go like this. If I am closing like this, NEI should go like this. And if I am closing this one, both should go. Inside, why I tested because first you want to create NEI folder. Inside that you want to create two subfolders. Inside each and every folder, add the files. Okay, you're working, still you're doing. Shall we move forward? Okay. See, manually creating folder, manually adding files doesn't make any sense. So then we have to create path for this. We'll create path for this. So the path creation is somewhat difficult. Difficult trick. That's it. Then click on to right click on to light anomaly detection. Right click on to light detection. Just right click there. Go to properties. Right click. Go to properties. This is important step. Don't skip it. Go to properties. Right click on your project. Go to properties. You have been confused. Then expand C bar C++ bin. Expand C bar C++ bin. Expanded. Then go to settings. Click on to settings. First go to MCU bar MPU settings. Right side. Then enable this one. Print the function first. Don't click on to OK. Don't click on to OK. Then go to MCU MPU compiler. Go there. Then here go to include path. We are going to include path for INC folder first. Then we will go to libraries. Then we will create path for LIB folder. So click on to add path here. Add path. Enter the path. Then type here. Not typing. You can just drag it from workspace itself. Go to workspace. So this is my light anomaly detection. I'm just expanding this one. If I expand, I can see nano HJ folder. I will expand that also. And then right now I'm creating path for INC folder. So particularly I will just select INC folder and I will click on OK. You understood? Then again press OK. So path for INC is completed. Then go down. MCU, MPU, GCC, linker. So GCC linker, go to libraries. Here, down, library search path, we will add path for library. See here, library search path, down. Down you can see library search path. So library search path, click on that. Here also, same procedure, go to workspace. Then select LAB folder, click on to OK. Again press OK. Then top side, libraries is there. See what's our library name? LAB NEA.A. Is that LAB silent? It's a folder name. LAB silent. Then just type there small letter NEAI. It's a library name. LAB silent NEAI small letter. You just type there. Then it is typing. Click on to OK. Click on to OK. Then apply and close. Is that okay? So this deployment code I will share. Just a minute. Check. Let's see this code will work or not because Energy Studio updated. Let's see this code will work or not. Just first after wait. I'll just check it whether it's working or not. Wait, give me 2 minutes of time. It's a new code. I'm just checking whether it's working or not. Because your nano needs to be updated 5.1.1. Previously it was in 4 series. Same drive. Morning I shared one drive access, right? You got the same drive. That will just delete the existing main.c file. See this existing main.c file, I will delete it. Then I will add new main.c file. This new main.c file I will add. New main.c file I added. Okay. You can download it. download it and you can add it in the main.c section. After adding, just check what node changes I have made here as compared to data logger code. Previously, void log and void fill and buffer. The functions were there. So I added three functions now. Void fill and buffer. So total three functions. If you are facing any confusion, just let me know. I will explain all the steps again. Your important step is ML model creation and deployment. Second and third step. Step you know, right? Just copy. Yes, you check in your mouth. And how I will explain. Try to understand the code. Which very simple. Three functions I added there. Void trade, void inference, then void fill and buffer. First I created a for loop of length of access number, not buffer size of 256. Then I added each and every sensor sample to that for loop. Then that sensor sample, I'm taking for training the data. First I train the model. The data I will take for training the model. Then after that, one more function, what is inference? Inference means similarity score, it will be displayed. And you can see everywhere nano, HCI, init, something. That is the function. API functions. So it is nano HCI functions and all the ML models. Understood? Any step you are in confusion like data logger, model creation, or in deployment, any step, any doubt to that? So you are getting output, not getting that doesn't matter. You understand the step or no? Well, it's easy. Simply, very simple. You can do it by your own. You can integrate other sensors. Just a foundation so that you can do. Issue you are facing? What issue you are facing? Create a model which you are model. That is done. So that given. I hope everyone copied and pasted the code. So you have to identify PH Johnson by 0. Input output string std input means to verify whether it's true or false. Actually, we are using this one. Then animate.h. Then here also data input user first size. This is number 1. And number learn iteration. Let's say number learn 40. You will train your model for 40 number of cycles. That's 40. And also here same variable. One more variable extra light will come. 3 function. Void fill light buffer, void train, void inference. Then user code begin for this function void fill light buffer. Filling light buffer inside a buffer sample. For loop we create 0 to 256. Then void train. Using the success sample to train the model. Using this function. Then void inference means based on the training you will get the inference. So here training should be done continuously. So I will copy this train function and I will paste it inside while loop. Train and inference. See here train inference. Okay. Initialization false to all the things. Once it is done, just click on the build icon. Ensure you are getting 0 errors and 0 1. If you are getting any errors, check it. Then deploy, debug the code, the console, same procedure. Debug the code, open the console, verify. You got? If your model, the main stage is that model bit. If it was collapses means everything will collapse. Yeah, similarity is 4. That's why I told you can use one if else condition also. If my threshold goes beyond 90 or after 90, you can make manuality thinking, humanity thinking, or not. Changing this condition, if it's condition without threshold. Okay, so that's all about the NCI project. Any doubts? Any doubts? Any doubts?